Good day. Today we are going to talk about LCM and HCF of algebraic terms. In our previous class, we discussed the addition, subtraction, multiplication, and division of algebraic terms. So, today we are going to learn how to find the LCM of algebraic terms and how to find the HCF of algebraic terms. We begin with LCM of algebraic terms. Before then, let us quickly recall what we did in division of algebra. We said that if we have 2a over 2, for instance, we have 2 here, which can go off with this to be left with a. If we have a number like 2xy over x, since x is up here at the numerator and x is below as the denominator, it can be wiped off to have 2y as your remaining answer. So if you can recall this, then question on LCM will become very simple. So we go with the first question we have here, A. We have 2x and 4xy. Just like we did with LCM of whole number, real numbers, we have a table drawn. Then we look at the numbers. What is the common terms we have here? The first we can think of that is a number, we have 2. 2 can go into 2x to be left with x. That is 2x divided by 2. 2 can cancel 2 to remain x. And then we have 4xy divided by 2 to give us 2xy. The next term is 2 again. 2 can still go. X divided by 2, since we cannot do that division, we retain our s as with the other sort of LCM of numbers. Then 2xy divided by 2, we have xy. So the next term we are going to consider is our s. So x is here, xy. We have x here also and xy. So x divided by x is 1. And xy divided by s will give us y. We have xy over x. S can cancel s to be left with y. Now we have y as the only unknown term remaining. So we have a y. 1 divided by y. Since it cannot, we have 1. Y divided by y will give us 1. At this point, we have 1, 1. So we are to multiply these terms to give us the LCM of the number we are looking for. LCM now will become 2 times 2 times x times y. So 2 times 2 is 4, and 4 times x will give us 4x, and 4x times y will give us 4xy. Therefore, the LCM of 2x and 4xy is 4xy. Then come to the second question. We have 3a and 6ab. Just like we did there, let's put everything in table. 3a and 6ab. Okay. We begin with the first factor that can go into this. 2 can go. We can decide to begin with 3. It will not affect anything here. But let's begin with the lowest number that can go into this and this, which is 2. 3a divided by 2, since we cannot have a whole number or a whole term, let's retain 3a. 6ab divided by 2 will be left with 3ab. The next term to consider now is 3. 3 is here. 3 can also be found here. So 3a divided by 3, we are going to have a. And 3ab divided by 3, we're going to have ab. Now, the next term is A. A divided by A will give us 1. AB divided by A will give us B. The next term is B. 1 divided by B cannot, we retain a 1, and B divided by B will give us 1. So the LCM of the expression will become 2 times 3 times A times B, which will be 2 times 3, 6. 6 times A, 6A. And 6A times B is 6AB. Alright, now we talk about HCF of algebraic terms. Just like we did with LCM, we are going to do something of that nature with HCF. But remember, HCF stands for highest common factor. So, we are going to look for the highest common factor of 18AB and 3BX. That is the number that can go into 18AB without remainder and can also go here without remainder. So that is what we are going to look for now. As usual, let's draw out our table. We have 18AB and we have 3BX. At this point, we're going to look for number that is common to both, or a term that is common to both that can go into both. This time, we are not going to consider one at the detriment of the other. Rather, we are going to consider both terms together. So what number can go here and can also go here? 2 can go into 18, AB, but 2 cannot go here. Therefore, we are not going to consider that. 3 can go into 18AB, and 3 can also go into 3BX. So, we have to consider 3. 18AB divided by 3 will give us 6AB. And 3BX divided by 3 will give us BX. Now we have 6AB and BX. What is the term or number common to both now? If we talk of 2, 2 can go into this, but 2 cannot go here to give us a whole expression. A is here, but A is not found here. B is here, and B is here, so we consider B. 6AB divided by B will give us 6A. And BX divided by B will give us X. That is, BX over X. X can cancel this to be left with B there. Therefore, we have 6A as 6AB divided by B, and X as BX is divided by B. Now, what is a term that we can think of that is common to both 6A and X? No other term. So we cannot move further from here. We simply multiply what we have here to give us the HCF. HCF of this will be equal to 3 times B, which will give us 3B. Now, the second question, we have 4A and 12X. Think of a term that can go into this and can also go into this. We have 2. 2 can go into 4A to give us 2A. And 2 can go into 12X to give us 6X. Therefore, 2 can go. 2 here will give us 2A. 12X divided by 2 will give us 6X. Now, 2 can still go. And so we have 2 here. 2A divided by 2 to give us A, and BX divided by 2 to give us 3X. Now, let's think of what is common to both again. A is here, but A is not here. 3 is here, and 3 is not here. So nothing can be found common to them anymore. We now multiply our factor out, HCF will become 2 times 2, which is equal to 4. So the HCF of 4a and 12x is equal to 4. Anytime, any day, this method will work for you in looking for the LCM or HCF of number. But note the difference between the two methods.